Hi, my name is Blaise and I'm here to present my learnings from Architect 235. Using Rhino, I learned how to create projects that can be CNC milled, laser cut, and 3D printed. Starting with CNC milling, I use the background bitmap, which uses an image from my computer and places it into Rhino. Creating a surface, turning on to control points, I can manipulate the surface in the X, Y, and Z axis to make it similar to the plane. Then, to direct the path, I use the contour command to make vertical lines run along the surface of my project. Then to act as a material, I used the bounding box command, which made a box around the project. Putting it into the Rhino cam and doing all the settings, I was then able to get my result. The image on your left is the simulation from the computer. The image in the back and on your right is the actual CNC milling using blue foam as the material. Skip the video. Getting into laser cutting meshes and facades. In order to make it easier to do laser cutting, we had to rebuild our surface to make it more blocky. That was done with the rebuild command and making the degree count to 1. To make it even easier, we divided the surface into strips. I made mine with the contour command but diagonal lines. Turning on the control points using the line command, I was able to create my triangles by connecting them together. Now that we have individual strips, I took each one, used the unroll surface command to make them flat. This makes it easier to do laser cutting. By putting into the laser cutting machine and program, I had to change the colors of my lines. The outside were made red because it reads it as cut, so that way each individual piece can be cut. The blue lines were etched, so that were my meshes, so that way I can fold each of my individual strips and piece them back together. Going into facades, I had to do research. I wanted to make my project into a wireframe, so I had to research on how to make it that way. To do that, I selected the surface, turned on its control points, selected a few, and moved them in the Z axis to make it more complex. After doing that, selecting the surface again, I used the extract wireframe command. With that, it only selected the curves of the surface and I was able to move them on the side. I wanted to then 3D print my project, which helped me compare my project in reality. To 3D print though, simple lines cannot be made. So to do that, I had to pipe each of my lines so that way it would give it a volume. The next step to 3D printing was saving my project as a STL file. This is the project as it was 3D printed, after being 3D printed. There is a typo saying remove excess ink. That is actually remove excess building material. Building material is material that is put within the negative space of your project to help support it while it is being 3D printed. Comparing it to reality, I went back to the original file and saw that my pipes were intersecting. In reality, this cannot work. So I had to do research on it and found my answer, which were nodes. Nodes connect pipes from different angles. However, mine were from unexpected angles, so I had to do more research on that. When I tried it out, it looked a bit weird. When I did more research, I came to underwater cities. Underwater cities use spheres that are able to connect pipes from many different angles and make it look a lot neater. With that, my nodes became spheres, and my project became an underwater city. The other easy way to connect pipes were elbows. To make them, I had to custom make them by using the curves and their angles and making it myself. Now comparing it to the human scale, because it is a city, I had to rescale the wireframe so it would be big enough to fit people and so they were able to live in it. Then I had to look at the pipes again, increase its depth to withstand the pressure underwater, and make sure they're big enough so humans can travel within them to transport from one node to the other. This is how it would look like in reality, and to show the nodes as spheres and the elbows customly made to fit each angle. And that is my project on how using CNC milling, laser cutting, and 3D printing and how I can connect it to reality to make it work.